Okay, for the last one that we're going to do is this one, which is about an ejector seat and a small aircraft, and we're told that and it's been tested, and it's currently 2 meters above the ground. The ejector seat is fired with an initial velocity of 25 meters per second at an angle alpha above the horizontal, where tan alpha is 24/7. So here's the horizontal. Here's the ground. It's good to remember that the ground is 2 meters above. It's being fired. This distance is going to be 2 meters. And the ejector seat is fired at some quite steep angle, because tan alpha is 24/7. And its initial velocity is 25 meters per second. Okay, so we know that and we've got to find the vertical displacement of the ejector seat after 1 second, and to see if that is at least 16 meters above the position of the aircraft. Now, the position of the aircraft is the position of the seat. So this is from. So we're interested in is after 1 second, have we gone up a distance which exceeds or equals or exceeds 16 meters. So we need to consider its two components of velocity. It's vertical and it's horizontal. We're interested at this stage about its vertical component of velocity. Well, we know if we convert it, we know that the vertical component is going to be 25 sine alpha, and we know that the horizontal component is going to be 25 cos alpha. Okay, so I just put those in. I might not need them all, but anyway, cos alpha. Right, now the thing to remember is I'm not going to look up. I'm not going to use inverse tan of 24/7, and then look up sine of that angle and cosine of that angle, because we can immediately get sine, cos, and tan if we just draw. If we take our triangle and we just think of it as, if we just remember that from SOHCAHTOA that sine is tan is that's alpha, so we know tan is opposite over the adjacent, or 24/7. So let's call that 24. Let's call that 7. Now we can work out what the hypotenuse of a right-angled triangle is by taking the square root of the sum of the squares. Okay, and if you why am I doing this? Yes, if we so let's do that, and and lo and behold, you find that if you take that 24 and 7, you get 25 for the hypotenuse. So that's good, because it means that from this little red triangle here, we can immediately say that cosine alpha is 7 over 25, and sine alpha is 24 over 25. Okay, so going back to the question, what we want to do now is that, so we now know that now considering vertical motion, and basically we want to find, and we're going to take upwards as positive, and we're going to say we're interested in the distance that we travel upwards in 1 second. So we know that the time is going to be 1 second. We know that gravity is acting downwards, so we know that G, as we said, is 9.81 meters per second squared. So we're going to have that acting downwards, G. And it's and if we're taking upwards as positive, then G acts in the negative direction. So G, or the acceleration, I should say, is going to be minus 9.81 meters per second squared. We know it's 1 second. What time is 1 second? We know our initial upward velocity. So U is going to be 25 sine alpha. 25 sine alpha is 25 sine alpha, which is, plugging in alpha 24 over 25, we get the value of 24 meters per second. When you just plug in sine alpha is 24 over 25, and we want to know S. So when you do that, we get that S is 24 U times T minus or I should say plus a half times G, which is negative, A is negative, times T squared. And T is 1, so it's 1 squared. Now when you substitute all of that into there, you end up with 19.1 meters, which exceeds the distance of 16, so therefore it passes, therefore exceeds 16 meters, and therefore passes test 1. Okay, that's the first bit done. And for 9, if we go back to part B, another test the ejector seat has to pass is that it is expected to deploy a parachute when it reaches its maximum height. So find the height above the ground level and the time after launch at which the ejector seat should deploy its parachute. Okay, so what we're going to do here is we're going to say that the thing that we've got to when the body reaches its maximum height, its final velocity is 0. Okay, so if we think of that, so here's the ejector seat. Remember, it's 2 meters above the ground. So its starting place is is already 2 meters above the ground, and it's going to, and it's fired initially at this angle that we mentioned, but then it's going to reach a maximum height, isn't it? And so now we know that this initial velocity upwards in the vertical direction is 24 meters per second. So the upward is 24 meters per second from the first part, but we know at this point, when it reaches its maximum height, its velocity is going to be 0. So it's velocity is 0, therefore we need to remember to plug into our equation that information. So considering vertical motion again, where upwards is positive, we've got u, if we're going to use to find the maximum height, we can use, we're going to be able to use the fact that we know our initial velocity u is 24 meters per second. We know our final velocity vertically, v, is going to be equal to 0, because it's, if you like, you could call this uy and vy, because we're looking in the y direction. If we treat this direction as y, if you treat this direction as y, as opposed to this direction, which is x, you could call these uy and vy, but I'm just going to leave these as u and v for this question, because we're not going to, there's no calculation involving x, this direction, so we might as well just call these u and v. But bearing in mind that we're only considering the vertical motion. So u is 24, v is 0, a is minus 9.81, and we're after s, the distance we want, and that will be the distance above our starting point here, s, or the maximum height. S is what we're trying to find. So when you plug that in, well, what equation we're going to use, this time, instead of using s equals ut plus half at squared, we don't know what the time is, so that's no good to us this time. But the other Suvat equation is v squared equals u squared plus 2as, and that will do us, because that involves u's, v's and the acceleration. So v squared is 0, u squared is 24 squared, and then because g is a is negative, we're going to have plus 2 times minus 9.81 times s, and therefore s is going to be equal to 24 squared divided by 2 times 9.81. Okay, and when we rearrange that, we end up with 29.387, etc. Okay, which for now, don't forget, as I mentioned already or drawn the diagram, the fact that we start s is the height above the where the it's not the height above the ground, it's the height above where the aircraft is. So therefore we need to add on another, so height above ground is that plus 2. Equals 29.387 plus 2, which is going to be 31.4 meters to 3 decimal places. 3 significant figures, I should say. Okay, so that gives us the so that gives us the height, and to get the time, well, using the same information, we want one of the Suvat equations involving time. Well, we know v, u, a, so therefore we can use v equals u plus at to get the time. V equals u plus at So we have that V is 0, U is 24, A is minus 9.81, and we've got T. So therefore T equals, works out to be 24 over 9.81, which is 2.448, etc. Which I'll write down as T equals 2.45. Okay, so that completes the last question that we'll ask you to. That's worth doing. Okay.